So, quiet, thank you. So the next thing actually is like really dear and near to my heart because I've been bugging people for ages that we should have panel discussions, and this is a panel discussion. So today's panel will be about long-term storage. We have Fabian representing Thanos, we have Tom representing Cortex, we have Julius doing the moderation, we have Nikunj representing M3DB by Uber, and we have Paul from Influx. Thank you very much.
See you, Richie. Thank you. Thought I was going to do the intros. So, yep, this is us. You might be wondering, how did we get into this situation? I'm Julius, one of the initial authors of Prometheus. So I'll give some context about the history of storage. Richie already introduced the others. We'll get more details about their long-term storage approaches later on. And basically, the goal of the whole panel is to give people a bit of an idea of why do all these different storage solutions exist? What are the differences between them? Which one might be the right one for you? And yeah, so let me start off by saying, when we initially created Prometheus at SoundCloud, we didn't initially care so much about long-term storage. We needed a tool to give us actionable alerts right now and maybe, make it also easy to make them highly available just by running two. And it's a nice thing that there's also some data that you can query nicely, but we didn't care so much about, keeping data for years and, having gazillions of time series or, just split up your Prometheus servers. But then there were actual other users and they had all kinds of other different requirements. So in the end, we still said, well, we want to keep the Prometheus server itself simple because, building a big clustered system with possibly consensus algorithms and so on, that would be a bit of an antithesis to Prometheus, which we want to keep simple and want to have a focus on the right now alerting and monitoring. But we wanted to enable other people to build long-term storage use cases, or even just, even if you're not storing them, maybe you want to ship every sample somewhere else and do something with it. So we built a set of generic interfaces, which is called the generic remote read and remote write interfaces, where you can configure Prometheus to basically send on every sample that it scrapes to some remote URL endpoint, and that could be a storage, could be a stream processor, whatever. And for the reading, the same thing. You can point Prometheus to a remote endpoint where it can request samples based on a set of label matchers, and the querying, the PromQL, still happens within Prometheus. Now, I think in some of the solutions here, they are basically really based on this remote write and read interface. I think Thanos is probably the most different one. We'll hear about that. But yeah, so maybe my first question to actually the audience is, who is already using some kind of remote storage solution with Prometheus? That looks like a fifth, maybe? I don't know, something like this. Who isn't yet but really wants one, but just hasn't tried or isn't happy yet with the existing ones? Okay, that's actually the same amount of people. Okay, let's see. Yeah, why is everyone else here? Okay, so maybe my first question to each of the panelists would be, why does your solution exist, and what are the prime use cases that it solves? I mean, maybe, Thanos, you can keep it short because, of course, we just had the big talk, but yeah.
Yeah, I guess the main goal was with Thanos to actually keep the operation simplicity of Prometheus. So basically assuming that people don't really want to deal with operating a monitoring system, they just want to get the value out of it. So what's the minimum solution we can get to give people all the sort of missing features without adding any more headache?
So I'm representing Cortex here, which is a project we started 2.5 years ago, I think now. Who was at last year's PromCon? Okay, so you all saw the Cortex talk. For those who didn't, there's some excellent videos out there. The main aim for Cortex was to, as a service provider, offer hosted Prometheus. So we wanted to offload the long-term storage for your Prometheus to us, basically, and then obviously charge you money for it. we did this as an open source project, though, so you can run your own. And we were kind of pleasantly surprised when a whole bunch of people started running their own. And so there's now, I don't know, maybe 4 or 5 people you can go and buy a Cortex instance off of. And the same again, people who run it internally inside their own organization for long-term storage. But yeah, for us, it was mainly long-term storage we built it for.
So I'm representing Uber. So at Uber, we have a lot of metrics. So the kind of scale I'm talking about is, so I recently took some numbers. So we do about 400 million raw samples every second. So that's like kind of our scale. And so we wanted something which is extremely reliable and extremely performant. So a lot of people talked about how system metrics are important, and they are at Uber as well. So you want to know how well your service is doing in terms of latency, is any host down or things like that. But we also have a lot of business metrics. And what we've seen at Uber is a lot of products have actually come up using our metrics platform within Uber. So there's a product which actually looks at number of trips happening in every region, and you use that to forecast how many trips are going to happen next week, things like that. So we needed a system which is extremely performant, extremely reliable, which can work for longer-term metrics as well. And that's why we built M3.
So I'm representing Influx. So initially, the long-term storage, Influx's support for long-term storage started with this conference last year. I gave a talk about the integration stuff of integrating Prometheus and InfluxDB. And actually, I wasn't presenting any code that we had written, but code that Julius had written about pairing. He basically created like a long-term storage gateway to Influx. And the reception at this conference was so good that we decided to actually add first-class support to the database to that. So now InfluxDB supports both in the open source and in our commercial stuff, the remote read and remote write endpoints. Yeah.
Yeah, and I believe yours, M3DB, does as well, right? Remote read and remote write?
Yeah, that's correct. Oh, I've missed that part, I guess.
Cortex also does. Thanos is its own beast. Yeah. I was wondering, so we have some of these solutions which go for this horizontally scalable clustered approach. I think InfluxDB, M3DB, Cortex are all representative of that. Thanos takes a really different approach of going like, oh yeah, you keep your Prometheus setup as it is, and you just add little sidecars everywhere, and then you kind of, Thanos scales together with Prometheus, but that has the upsides and the downsides of Prometheus. What do the... Yeah, I wonder what my question really is.
Leading the witness.
Yeah. No, I was wondering, like, what you think, let's say, for example, Paul, about the trade-off between having... Or actually, no, Tom, because Tom was the original... Cortex was the first big, long-term storage for Prometheus, which took this completely different set of trade-offs where you say, well, we're going to build a big clustered system instead of many little individual independent nodes that don't have to coordinate tightly with each other.
Yeah, so from my point of view, the fundamental trade-off was we needed a product that when people pointed their data at it, they would instantly see their data in the hosted platform. It's not particularly acceptable to a service provider if it's like, oh, just wait 2 hours for a block to upload, for instance, with Thanos. And that, I think, is the big difference, right? We were aimed at providing a service to users, and Thanos is aimed, as you said it really well, like growing with your Prometheus cluster, and so can take a really different approach. And that meant we had to do the samples. There wasn't really any other option. In fact, the only other option that's now coming up you might want to talk about is something that Fabian's working on, which I think is awesome and we want to support.
We talk about that? Yeah.
Sure.
So like my problem with the remote write has always kind of been that it's, flaky, let's say. Or if you have a network flag or something, you're losing data in the end, right? You can buffer samples up in memory to a degree. That's maybe 5 minutes, but eventually you just have to drop data. And that's always seems like suboptimal because the network is flaky. So what I always figured is with this new storage we have a headlock, which is essentially, it's a persistent buffer of all the data you have written, at least for a couple of hours, and would be ideal if we could just stream this write-ahead log somewhere else. And if we have a connection failure and sort of are blind for like 10 minutes, we just come back and we just pick the write-ahead log back off where we left, essentially. And then we don't lose data, at least for a quite large sort of time window.
This is a new development, right? So basically, the challenge is always between either you ship your samples immediately as they get scraped to some remote system, then they're safe, they're durable, you know. That's awesome, but then you're sending them in the most inefficient representation ever. You need to marshal them, each sample to protobuf, send it over the network, yada, yada. That's cool, but yeah, then, you know, if you don't buffer it also locally, you're not resilient, it's inefficient, etc. It's really efficient the way Thanos ships full compressed blocks as one thing, you know, once they're persisted to disk, but yeah, then it takes hours for them to actually migrate to the destination storage where they're safe and durable. And if you lose your Prometheus server in the meantime, you're kind of out of luck. Yeah, I was wondering, so now you have this intermediate approach where you say, well, we ship the blocks, but in between we also want to ship the wall, or you just do the wall now. That's your idea in the future.
Well, yeah, so there's actually a design doc out there, which we did like a long time ago. For example, in the Stackdriver case, where we want to get data from Prometheus into Stackdriver, we could use the remote write as well. Turns out it has some missing features like metadata, etc., and target information. So we wanted to have something better and also add this additional data, and that's why we wrote this write-ahead log-based approach, which is not public yet, but you can actually look at the design docs. Yeah, the benefit is that you have this resilience, and basically the total sort of amount of data throughput you need significantly goes down, because the remote write right now you have to send the entire label set and the data point, and with the write-ahead log, in theory, you just have to send basically the series ID after you send the series itself once, and then just the timestamp and the value, which sort of probably reduces your data throughput by 10x.
I just wanted to defend the remote write code a little bit. It was never meant to be like it's never meant to be as widely used. Like Julius, I think you wrote the first implementation.
Remote read, I wrote the first
maybe
one,
it was me. I can't remember. One of the two of us.
Brian? Yeah. Brian.
Was it Brian? Okay.
Remote write was Brian.
One of the three of us wrote it. I did the sharding code, which is pretty crappy as well. And like it was always supposed to be a prototype, and we were just super impressed when, like as Paul alluded to, like last PromCon, it seemed like a lot more people were using it than we were ever expecting, to be honest. And so I really welcome the new write-ahead log approach.
It's essentially the same thing, just in a more efficient format, let's say.
And we're going to support it in Cortex when it's public.
Cool.
Yeah. So just to put forward Uber's side of the story, I mean, we went with a clustered solution because, as I said, I mean, our QPS was extremely high. So first thing was we wanted to aggregate in a streaming fashion rather than like later on aggregate in like a batch fashion. So actually we did some analysis. If we actually did the batch fashion, then our aggregators are actually never going to be able to keep up with the load. So that was one interesting thing. And then the other thing we noticed was it's a really nice property to have wherein alerts are actually working off your aggregated data. So if you actually aggregate later on, our alerts will have to fetch all those queries and apply the aggregation later. So those were some unique things. And then we wanted it to be really reliable. So we do replication and all that. Like so in actually Uber production, we have a replication factor of 3. So I don't know if any other system has replication, but for us it was kind of valuable. So all these kind of made us move towards that clustered solution.
Yeah, I think we've all got replication.
They all do, basically. You've got Bigtable or Dynamo, and you've got S3.
But now everything is Go-based, right?
Yeah.
Go, yeah.
It's the future. Until we all switch to Rust.
It's the past, right?
No, I mean, it's interesting. Like, a lot of the older, like, big kind of data stuff was Java now.
Yeah. So I want to comment on the clustering thing, too, just briefly, which is Influx as a project it's not just scoped to metrics and monitoring data. So we went with a clustered solution because we want it to behave like a database, which is people have expectations of when they write and they get a response, it's durable and it's replicated and all this other stuff. So if you can avoid clustering, I would by all means recommend that because it's the worst thing to do ever.
Question, since M3DB is the newest one out here, just I think the blog post came out yesterday or the day before.
Yeah, that's correct.
Not about M3DB, but M3, which is the actual like Prometheus integration with an Uber. What are your hopes for the open, with like combined with the open sourcing? Like, are you what was the first reaction you got from the community? Are you getting a lot of interest already? What would you like to get out of that?
Yeah, that's a good question. So one thing I want to point out is making money out of a database is not Uber's business, right? So we wanted to make it open source with the primary objective that we're providing different components as part of M3, and people can pick which component they want. So people can use the Prometheus sidecar, for example, or they can use M3DB, or later on we might open source the aggregation tier so they can use that. So we kind of provide a way for people to pick and choose what they want. And regarding the reaction, I think when we put out the blog post, our initial desire was, oh, we want to be on the first page of like Hacker News or something, right? And we got there, and then, yeah, we got positive response, and people never heard about M3DB before, like a lot of people who talk to us. So one big push we are doing is kind of educating people about it. So previously, we had this system running a lot within Uber, and it has been working, but we never really pushed it into open source world. So this is something new we're doing. And now we think we're at a stage that it's kind of easy to use for people, and we definitely believe it's usable. So yeah, now we're just trying to educate and put our faces out and talk about M3 as much as we can.
Cool. Let's see how much time we have. We have time, but I mean, are there already audience questions? Because those are always more interesting than mine.
I have prom coins as well.
Oh, yeah. Thank you, by the way.
All right, great content so far. There's just one question. Why are there 5 dudes?
Yes, this is a very good question. It's, I think, not only a good question for this panel, but for the entire community and the set of maintainers. So I think, yeah, I don't know if I can give the best answer to this, but for this specific panel, of course, it's like, okay, who do we know who created each of the individual remote storage implementations? For the broader question, I think this is of making the community more welcoming and helping newcomers get into the project, but also without feeling, I mean, I could start a whole community discussion now. I think often we are a bit, maybe a bit of a harsh community, a bit of a community that looks the same in a lot of ways. And yeah, I would really like to see improvements in that as well. I'm doing privately some things that I can do, but I would sometimes, yeah. Also, I mean, it's yeah. I don't think I can give you like a perfect answer to that question right now, but yeah.
Just as an interjection, we also have the diversity funding within PromCon and all these things. So
Yeah, I mean it's a good thing, but also we have to improve a lot on that front. Yeah.
So my question is about multi-tenancy. I know that Cortex supports multi-tenancy out of the box. How far away are the other long-term storage solutions from being able to provide a multi-tenant storage solution?
Bob works for Fresh Tracks, who also runs Cortex. So he's definitely a plant here.
Thanos Multi-Tenancy, I think Bartek told me that he's working on something, like sort of a query gateway that allows you to basically do tenancy based on the label selectors. That seems like the way to go.
Paris?
So Bartek said that Improbable and Red Hat are both interested in this stuff, and they're probably going to work on it. And they both have a lot of development power, so that's hopefully going to happen.
Hey.
You just said that about multi-tenancy?
Sorry.
I just want to comment that yes, Prometheus invited a lot of us diversity people here. I guess I come from the States, so thank you. And from this all being brand new for me, I'm still in school. I don't know what M3 is. And my other question to the panel is, how do you find time to innovate and to create? I was just asking my colleague, and for me, I work a lot. And so how do you carve out that time so that, you know, one day we could be up at the stage, it's like, hey, I created something cool named after Marvel. How do we do that?
Can I actually try to give a tentative answer to that? Because I have been mentoring candidates. Like, a candidate by itself is never diverse. A candidate can improve the diversity of a group, and I've been mentoring some people who are interested in contributing to Prometheus, for example, who would make us richer and more diverse and more inclusive, hopefully. I mean, that's more on us who are already there. That's sometimes a problem. And a lot of times I see, like, they're interested and it's great, but then there's not a lot of follow-up, because without actual funding, which I also know from my personal experience, it's really hard to, unless you're like a super nerd and after your work you still feel like coding, to actually keep at it. So I think it's, unless you're that kind of person, we need more funding for this kind of thing. We need companies to employ more junior people, and to be more welcoming to them, and yeah, basically more mentoring and that kind of thing, because we need people to get paid to do this kind of thing, because we have like billion-dollar companies using the software in the end, and yeah.
Yeah, I'm gonna say something that may be a little bit controversial, but at least like early on in my career, if I wanted to do open source stuff, that was all during my free time and weekends, which was great. The vast majority of people who are writing code aren't doing it for open source companies, and they aren't writing open source code, right? The vast majority of code that gets written is closed source. So, I mean, for those of us who did get to write open source code full time, like in my case, like I did a bait and switch with some VCs and raised some money and got them to pay me to do open source. Other people get other big companies to get them. So if you can do open source code full time, but for me at least, doing open source was basically the gateway to events like this and all that other kind of stuff.
For me, it was also always a mix, but it helps. I noticed myself, for example, now I'm freelancing instead of being employed, and I get to do way less upstream stuff because customers tend to be more interested in support, training, and whatever features exactly they need for their company. Yeah.
I wanted to go back to the multi-tenancy thing really quick.
Yeah, but one thing. So we have Ask the Maintainers panel tomorrow, where you will encounter the same problem. You'll see it all on stage. But I would be very happy, actually, if we could continue this conversation there.
All right, I'm multi-tenancy really quickly.
Yes.
So most databases aren't designed to be multi-tenant. Usually you layer that in the application layer, right? Like you have your application layer protect your MySQL database against a bunch of tenants that you have in it. Usually when people do multi-tenancy in databases, what they actually do is they deploy it on separate VMs, and it looks like a multi-tenant system, but ultimately you're talking about single tenant deploys. Now, the next version of InfluxDB is gonna have this idea of multi-tenancy built into the API, but to actually make that operationally feasible is something that I think has only kind of come up over the last like 5 years of infrastructure software, which is, I don't think we've yet seen a database that was designed from the ground up to be containerized. And I think containerization is actually what can lead to actual multi-tenancy within a database system. So one of the efforts that we have with Flux was to decouple processing from the actual storage of the data. And the reason we wanted to do that is because we wanted to spin up new processing agents in containers that could be sandboxed so that we could have a multi-tenant system that actually was a bit more reliable than a standard database. But I wouldn't call it easy.
Okay.
I'm sorry to go back to the remote read and write thing. The issue I have is that when you ingest a sample, you lose the metric type. So when you're writing it to remote storage, you lose the fact that it's, for example, an histogram. And when you have native PromQL query, it's easy, but when you don't, for example, with Influx, or I don't know, maybe with M3DB, you lose the fact that this metric is an histogram and that you have to treat it as that. I've found that missing the typing information in the metric design is an issue for long-term storage. For long-term storage, yeah.
Yeah, that's the same issue we ran into. That's actually part of the reason why we went with a completely new approach for the stack driver work we are doing. Because simply, yeah, we need type information, we want target information, etc., etc. And yeah, once we publish what we have, that will hopefully be insightful, because we actually added APIs to Prometheus that expose the type and target information, and we sort of tailed the head dog to get the data out, and then we joined this again with the data from these APIs.
But the thing is, ultimately, Prometheus doesn't store that data anyway, right?
Exactly, that's the problem.
Yeah, so yeah, Prometheus doesn't store that data anyway, so technically that data is worthless. Like, it's just as useful in Prometheus or in a long-term storage solution, which is the fact that it's a histogram is recognized by what the labels look like.
Yeah, but it'd be incredibly useful, for instance, to hint it in the UI, right? That's one of the main reasons we want that data, is so that we can tell users if they're rating a counter,
right,
or not rating a counter rather, or tell users like that this is a histogram and should be treated as such.
So the question I have then is,
we're not allowed to pose questions.
I'm going to do it on behalf of the audience. Which is, okay, so that's storing the type information for long-term storage, but are there plans to put storing type information about the metrics within Prometheus itself and adding API endpoints so you can query that?
So I would love to do that, but I haven't discussed it with the wider community. Like, I think it's something
they accept pull requests.
Indeed, yeah. We had a discussion about full-time jobs and things earlier. Yeah, I think it's something we should do, and now you've put the APIs in, there's...
Yeah, like, we actually briefly considered sort of adding this to the storage layer, but like it seemed like a lot of effort, to be honest, for like just our use case so far that we would get value out of it. So I think we need more data points that this is valuable, because it will be a drastic change. And we have to convince Brian, which probably will take another 2 or 3 years.
He's so hard on Brian. Next question.
Yes, so the reason why so many people love Prometheus is because it's not driven by a company, it's driven by lots of different people who work together to achieve the same goal. But when I look at you guys, it looks like there is always like a company behind that. I would like to know a bit more about the governance, and if we choose long-term storage, we want the project to be supported in the long term as well, so that we have 2 years of data, but the software that runs it is still like used and maintained.
Maybe each of you just give a quick reply to that?
Governance is more like you.
No, yeah, I mean, well, Prometheus governance is our topic, but I think he's wondering about the governance of each of your, right?
It's like, yes. Because it looks like all of them are like made by a company that we don't know it will be there in 3 years, for example. Like in Prometheus, we know that maybe the people will have changed, but we have confidence that Prometheus will still be there in 2 or 3 years.
In my case, I think I worked for 5 different companies on Prometheus over time. I just always try to have the best for the project in mind, while at the same time sort of satisfying my employer's goals, let's say. So far that works pretty well. I think most companies today are quite open to being nice to open source and doing things right. So, well, it's a bit young, but maybe Bartek has thoughts already.
Yeah, from Thanos' perspective, I think, well, we designed Thanos because we had this issue on our own. So I think it's safe to say that Improbable will support the Thanos because we are using it, and that's our future plan. And we are completely transparent on that. Everything, there is no hidden like roadmaps or hidden, discussion. Everything is happening on GitHub, and we would like to be as open as possible. So yeah, that's an Improbable standpoint, and for Thanos.
Yeah, same for Cortex really. So I originally started, Julius and I originally started Cortex at Weaveworks. I left, did my own startup based on Cortex, and now I work for Grafana Labs. And so we've adopted CNI, the container network interfaces, like governance, just because it was short and sweet, and it's got a whole bunch of companies involved, so it's going pretty well. Sorry. I can keep talking if you like.
Just take this. Okay. Cool.
Oh yeah, and Cortex, we submitted it to the CNI, to the CNCF, and it's going through that whole process. We've got one vote so far.
Okay, so for Uber, I mean, we run M3 for Uber's metrics, so it's not like Uber is going away anywhere. So. Yeah, and and what we're doing now is, as I said earlier, that we build M3DB and the other layers internally, and we're open sourcing it. But going forward, we're actually planning to use the open source components directly within our actual internal systems. So that way, it kind of gives us a motivation to keep developing towards open source. And that kind of also answers the other question, right? How do you manage time? I mean, it's my full-time job now to develop the open source solution, because we're going to use it for our actual business. So yeah, in that way, we're kind of unique because it's deriving our business. And yeah.
Yeah, so speaking as the one representative who is selling a database, we try to, I mean, in terms of this, like we try to conform to whatever APIs are standard. This is one of the reasons why I'm excited about open metrics as like a standard. We want to support those standards. Like we don't want to hold people's data hostage, but regardless of which project you're using for long-term storage, the simple fact is like data has gravity, and the more data you have, the more gravity it has. So even if you're based on a totally open solution, it's totally free, it's based on standards, you're going to have lock-in with wherever your platform is, wherever your hosting is. So the idea of no lock-in, it's a myth. Don't believe the hype.
I think we have the answer from Thanos, but how do the rest of you handle write back in the event of a network partition?
Right back in the advantage between your Prometheuses and your Cortex cluster, you mean?
Yep.
Yeah, so there's a small in-memory buffer in Prometheus. If that gets exhausted, you drop data. We're hoping that the write-ahead logs work that Fabian's doing will solve that problem. And I guess it's the same answer. It's way more interesting if you talk about within a Cortex cluster. Sorry, it's way more interesting, but we don't have time to talk about what happens within. Like, what happens, we have a different replication scheme, and we can do all sorts of different tricks to, like, if you can't reach certain parts of the system.
So what he's saying is you don't get a token for this question. I think he's out anyway. Next question is Oi.
I was going to follow up on what you were saying before about the long-term support of systems. I think this applies to most systems out there that are offered as free software or open source. In general, my rule of thumb is like, I will trust a lot more a project that is community managed, that's not tied to a single company, and I think Prometheus is a great example of that. It started in one place, but it was not managed by the company, and then it became completely independent.
But do you write Go?
Sorry?
Do you write Go code?
Yeah.
Yeah? And which company manages that project?
Right, well, it's not perfect.
Yeah.
But I think in general, is my point of view is that I will trust more a project that has a governance and independent a company.
Yeah, I mean, I think it's a good point, but these communities take time to build.
Yes.
Right. I think Thanos' community is going pretty well. Like, even though it's done by Improbable, like, the community's got quite a lot of contributions. Like, Cortex has been going for 2.5 years, and we're still a relatively small community, but there's 4 or 5 companies involved in it. I guess, like, yeah.
Yeah, I mean, actually, once we have a community, we'll actually prefer registering with CNCF and being completely community built, you know? I mean, it's not like we want to own a database. I mean, we are not a database company. So it's just that we had to build a database because at that point, there was no other alternative we saw which could solve a problem. But right now, we'll be happy to make it a completely community-driven project.
Please don't take it as a personal attack.
What are you doing to embrace the community?
Oh, I mean, right now, as I said, we just published a blog post, right? And now we're trying to tell people about M3. So first, educate people about M3. And then we're trying to build a community. So we have like I think a glitter channel where people can come in and like give thought. And we're always open to contributions. I mean, but all that comes later on when people actually know what M3, like, so we'd be happy to take in any contribution, any like issues you want to open up. I mean, completely. And later on, when we feel it's the right time, then we can consider registering with CNCF. I mean, if we feel we get accepted. I mean, if you guys want, we can submit it.
Yeah, sorry, I didn't mean to be flippant about the community thing. I mean, different governance models, like Kubernetes and CNCF, there's BDFL. Ultimately, I think open source thrives off of continued contribution and continued community effort, regardless of what the governance model is. I think Go doesn't have that sort of community governance model, but I think it's so successful because there's just so much effort getting put into it, and they do seem to try to listen to the community, even though sometimes there are issues. But I ultimately, for any open source project, I think it lives and dies by people's continued effort to improve it and move it forward.
So unless you want to see me make Julius sing and dance, maybe ask more questions. Ich und mein Holz.
So Richie already pulled a prank on me, which I have to tell. My name on my badge is Holz instead of Volz because there's like a funny YouTube video, Holz means wood, and then he lost my real badge, and now he can't find it anymore. So yeah, I'm stuck with this one. So in case you were wondering why my last name is weird on here,
it's his actual name.
Hi. This might be a bit of a naive question. We're just starting out with Prometheus, and obviously everything you hear, the original Prometheus model is like, here's this quite simple thing with local storage. But at the same time, we're looking at building out into like Kubernetes and ephemeral, a lot more ephemeral instances. Is this the way forward? If you want, does this unlock your ability to have a more scalable, more dynamic Prometheus offloading to long-term storage? And are there patterns around this?
Who would most like to answer this question? Maybe the Prometheus-ish?
I guess the decision really is between Thanos and...
Trying to understand the question, you're thinking like you have Prometheus servers that are not around for like a long time, and okay. Yeah, I think in this case right now you're better off as a remote write solution because the data gets out immediately, right? In Thanos, currently, this data set you have to wait for like 2 hours, so you would have to sort of turn on keep the Prometheus server live and then wait until this sort of data gets shipped. That's something that's on the issue tracker, I think, to sort of get worked out. But I would hope in the long term that's not a problem for any of these solutions.
Your data needs to live somewhere, right? Yeah. And all of us rely on a very similar technique for building up these chunks and getting this compression. And that's how we all get very similar costs. So you need to have something running for some length of time that can build these chunks.
Yes. So for at least for the time being, you still have to care about these Prometheus instances that you've got running in your Kubernetes cluster.
Yeah, if you use Thanos, you have to care about those. If you use Cortex, you have to care about Cortex. You still have to care about something.
Yeah.
Yeah, I remember with Prometheus 1, we were able to switch off the local storage completely and only have it in forwarding mode to remote write. That isn't really possible anymore with the current 2.0 storage. Though you can configure it to like minimal retention, you still need to have like some memory file system or something to make it work. But yeah, so there was this approach already a bit to make basically like a storage-less Prometheus. Yeah.
So I know that most monitoring systems tend to fall in either, as I may stand up, most monitoring systems fall into either operational, making sure things are running properly, or into data analysis, predictive, let's explore and see what's going on. Prometheus obviously is mostly for operational stuff, and I'm wondering for the longer term storage, if you have a particular focus on one kind of way to consume the data and the implications of designing for that.
I think you probably have more interesting ways of consuming data, at least.
Yeah, I mean, I have an opinion. This doesn't really reflect where we are now, but where I would like us to go, which is, and this is one of the things why I mentioned Arrow, why I'm excited about it, is because Arrow is a perfect like interchange format to to send off to other systems like Hadoop or Spark or whatever, if you want to do like large scale analytical type processing and stuff like that. Influx by and large is built as like a real time kind of database. So it's mostly like you're querying frequent or recent data. But what I would like to see us do eventually is support data formats that can be shipped to other systems that are better at doing like analytical processing or stuff like that. And I'd like to help add that support to Prometheus.
If I understand the question correctly, I mean, so we, as I mentioned earlier, we want to provide a platform which can give you quick access to metrics, however long retention you want. And using that, we've already have had different ways to consume data. So we've had a product which can forecast trips, using the last 2 months of trip data. We have anomaly detection using our metrics platform. So I don't know if that's what you're referring as to consume data in different ways.
So you all play with, it's me, you all play with remote read, remote read interfaces, except Thanos format understood, but what would you improve them, and maybe would we promote them to be like used by other systems than Prometheus, so that you can make interaction between Prometheus or InfluxDB or Graphite or any other system out there, so that the Prometheus itself can be like changed with something else?
I mean, one thing we've noticed is that remote read write is kind of like best effort. I mean, if it has a buffer, but eventually will drop data. So that is one of the concerns we have. So that is something we'd want to improve. And then there are other things which you talked about earlier, like maybe supporting type information, or like for cross DC, there are some things which we want to add to the API. So yeah, I mean, there are some things.
The read can quite easily your Prometheus server if you're not careful. So like that clearly needs fixing, right? We need to move to a streaming interface there. I mean, that's what the sidecar does basically. So we need to do that. Like, yeah, the read's only really a prototype. I don't know anyone who actually uses it in anger.
Yeah, the read interface is basically you send an HTTP request with like a batcher and a start and stop time, and it sends like a batch of the data. So basically it has to marshal the entire result in memory before it sends it back to you, and it's this like protobuf blob. So the thing that I'm actually interested in adding to Prometheus itself, or whatever, to define as like a remote read protocol, is essentially still gRPC, but instead of sending one block, design it more as like a batches, like micro batches, where it can stream the data out in chunks. So you could theoretically send a query to a Prometheus server where you want to do a remote read, and you do a remote read of the entire contents of the data store, and it could just stream that out, right? Whereas right now, like if it was a large data store, you'd blow up your server.
Is anyone thinking yet of completely feathering, like distributing out queries in the sense of doing local aggregations and stuff, rates? Yeah.
Yeah, so actually that's one thing I'd like to see. Like right now, the remote read is you push down the matcher and the range. What I'd like to see is being able to push down other things like aggregates and stuff like that. And that's what we're doing like in the InfluxDB design with the Flux engine, is it's basically, you can think of it as like a map reduce that gets run on the fly, where the map phase would get run on each of the Promethei or whatever service that supports the Prometheus remote read logic, and then the reduce would just be done by, in our case, the Flux node, the coordinator node, essentially.
Yeah, I'm kind of against this at this point. I mean, not in general as approach, but for Prometheus, like what we noticed in Thanos was the data is actually not that big. Like even for big queries, like hundreds of megabytes, even like gigabytes of gigabytes, it's not that much data, to be honest. You can ship this somewhere and process it, right? The processing will take longer, so it would make sense to actually shorten the processing. But then in Prometheus, you have this problem that actually you have aggregations over time. And how do you solve that? If your data is sharded by time, then you have to sort of, the overlapping ranges, you have to ship them around to actually get the full aggregation, right?
Yeah, it depends on what aggregation you're doing and what the sharding mechanism.
Yeah, I mean, vertically works kind of, but sort of horizontal.
Yeah, it depends on what sharding mechanism you do and what aggregation, but like T-digest, for example. Or if you're going to use hyperlog log for counts, right? Those those can be distributed across shards, and then you can combine them up in the resulting node. So it depends, basically.
Yeah, I mean, definitely makes sense in general, but I think Prometheus is not at the stage yet.
There's one type of query which I've encountered with the customers where they're using Thanos. They have like millions of metrics in their Prometheus server pointing Thanos at it, and then the problem is like if you want to run a debug like query like give me the count for every metric name, which has a low output cardinality, but you need to ship over the identity, even if it's just the right now timestamp to the querier. It needs to go to like through the remote read, marshaled into Thanos gRPC, and I think it would be similar problem with some of the other approaches. So just that, give me that summary at the current timestamp, which metrics have how many series, isn't possible, and it runs very easily with the local storage because it can do like lazy evaluation of iterators and all that. So I think there's more need for distributed querying than
that particular case comes up a lot, like this particular query, and I think it's metadata, right? You don't care about the time series data in this case, so you actually would want to have another API to do this kind of analysis.
Right, but I mean, it's a debug style query, but if we could like totally ship over that query, like we just get the result back, it would be really cheap. But shipping all the data to the Thanos courier kills.
We kind of have an API to do that, right? It's called the query API. We can just ship the query to the.
Yes.
So.
Yeah, I mean,
I think
the question there is more like how do you combine results in a distributed manner from multiple.
That's a query engine and a query planner challenge, right?
Follow-up. So actually, adding to what Fabian said, we are also building our query engine now, like a new query engine in open source. And this is a topic we discussed at length, whether to ship computation off to remote storage nodes. But after we analyze the data, I mean, the actual compressed data is super small. So one thing we found we can do instead is to actually ship back only the compressed data. So we don't decompress data and return back all the compressed data and be able to decompress it on the fly. So that actually reduces the memory footprint at the query nodes a lot. So that after doing that, we actually found there's no real need to do distributed computation, and it also solves the problem of how do you how do you stitch together different data pieces. So that's something you can think about.
Thanos does the same. It ships around compressed chunks.
Perfect.
Oh, Influx too. Okay. Cortex.
It's not that big a deal. We pretty much do the same thing. We fetch the query will fetch compressed chunks from the chunks.
All right. Yeah.
We don't do it for the last 15 minutes, but other than that.
Do you decompress everything before processing, or can you?
No, we iterate through them now. Although that only changed in the last 6 weeks.
Yeah, that is like a big difference.
Cool. We're probably nearing the end of the slot. Rishi, what do you say? One more. Okay. More questions.
Okay.
There's one there. Okay.
One question when we talk about the remote storage. It also would be interesting then Mr. Paul mentions open format, and I'm not sure 1 year ago there was some ideas that it will be published, but I haven't seen any things that would enable to use any of those databases to insert from other sources the data into the time series database, and then you can fetch them and analyze and make it more transparent. Yeah, transparent overall. And so my question is, when you plan to release, maybe, I don't know, open standards that maybe we can or is it somewhere discussions going on that we can contribute into it?
I think the problem is right now, so Thanos and the Prometheus format are basically the same, which is the blocks, right? The compressed blocks. M3DB, I think, uses its own. Influx uses its own, these are all just variants of the same thing, which is basically the gorilla compression. So the question is, can we all figure out one to standardize on, or is there, I think it's not just the blocks itself, but the other pieces of metadata that have to be standardized. And like I said, I'm particularly to Arrow, but the problem is Arrow doesn't specify compressed types, which is an issue. So that's something that we may be asking them about, but yeah.
It's also a question of how you go around building these standards, right? I mean, we know we put out the read and write format for Prometheus, and they're open standards, if you like. They're just a protobuf description. but we also know they're pretty weak in certain areas, and we kind of are discouraging people from holding them up too high. Like we've got, Richie's going to talk tomorrow about open metrics, which is more on the ingestion side. Like we want to build, you build these standards by getting a consensus among like people, and there's not really, I don't think, the push to do that. Like it's not in necessarily any of our interests to do that at the moment, and I don't know, these things are quite simple and quite interoperable as they are. There's little adapters that live all over the place. So it might be a pain in the ass to join them together, but it does exist. Like you can make Influx talk to Prometheus and Prometheus talk to Influx. And
yeah, I think the thing that sucks about that, and again, it's why I keep coming back to Arrow, is like to integrate these things, you have to decompress the block and then recompress it and translate it and whatever. The nice thing with Thanos and Prometheus together is like they can just ship compressed blocks around with actually without having to analyze them, right? So you can get like zero copy semantics, which is, again, like because Arrow is focused on zero copy semantics, that's like, if you had compression with that, I think it could be, but it would take a lot of effort to get everybody to standardize.
Like to get everyone to use that same format, and for what benefit? Like most of my customers are going to just use one or maybe two formats, and it's very hard to build a case to put a lot of effort into, a big N-way compatible format. Sorry, like, it'd be cool, but like.
So my question is to the audience and the panel. Is anybody actually just using Prometheus storage long term? Yeah, me too. It's working great. So long term, it's already built in, long-term storage.
Can I ask you, how long is long term?
10 years.
9.5 months, good. Yeah, because you've got some really big Prometheus servers, haven't you? Right, so that's what, 3 years? Yeah, no, I think it's a valid point, but do you back it up? Right, yeah, I mean, that's a good strategy, right? For those without a mic, how big was it? Just under a terabyte.
Yeah, I mean, we design and code the local storage a bit with the fact in mind that it's not meant for that long. I mean, people do it, but then once in a while we're like, okay, maybe we do a breaking change, or maybe we don't care so much about durability and replication and so on. So now you have to have like multiple replicas on your own to make sure that the data really sticks around. Maybe you need to operate older Prometheus versions, migrate somehow, or so. yeah. So just you're a bit more on your own when doing that. Yeah.
I have a question, more like a request. We know about Cortex, and we just learned about Thanos. So I would like to see a lightning talk on M3, perhaps later this evening or tomorrow.
I mean, I submitted it, so.
Otherwise, we would have to wait another year.
Yeah, it's number 8 on the list. We will get to it. So just in relation to the standardization, as Tom says, remote read and remote write are pretty weak. And this is by design. They are literally the stupidest thing that will work. And because the thing is, we don't want to prescribe how you design all this stuff. If we prescribe what the block looks like, that would mean that we're deciding how all these remote storages will end up working. Instead, we're saying, here's something really, really dumb. It's a prototype. And now, like, we figured out, actually, remote write is a really bad idea. Let's use WALs. Wonderful. We've now solved that, and we can do the same with read. And we'll figure this all out and figure it out by everyone trying stuff and making it better.
Thank you for solving that very big issue that we have in Prometheus with long-term storage. But in a few words, what would be for you the next big thing to solve after we have solved the long-term storage issues?
For Prometheus in
Global
general.
warming.
Oh, I maybe would let other people answer that. Who wants to answer that? Brian? Fabian?
Feature complete. I don't know, like I've been kind of out for the last 2 or 3 months, so I will hand this question up to someone who has been involved.
I mean, outside of Prometheus, I'm working on logging. Like, I think that's the next thing.
Yeah, I mean, that's the scope of Prometheus so far is pretty well defined, and we don't want it to blow up into something that is too far beyond that, because the simplicity is a lot of its strengths, as Paul also mentioned, saying no to some things. There's still some roadmap map items like making metadata, making better use of metadata of time series. Like if you go to the docs and then introduction and roadmap, there's some items, but they're fairly minor. Yeah, I think the general scope is what it's now.
Do you guys have plans to enhance the query engine? Or because right now it has a limit, and some people have asked if you can increase the series limit.
Oh, the 11K points limit. Yeah, well, so you can actually get more points out if you want to have raw export by doing an instant query with a range vector for raw series. You can do that. Just if you do a graph query for an actual graph, then it is limiting you to 11,000 output points. But yeah.
Okay. Okay. So long-term storage. What I'm hearing that this may be an alternative from using, I hate to say Azure storage. And if it is, what is the capacity? I mean, could we hold a petabyte of data, and can it be secure?
I could probably even answer that. You mean like with any of these solutions? Yeah. I think who trusts themselves to handle a petabyte?
Yeah, I mean, we do petabyte easily. I mean, it... Sorry, I don't want to come off. But it all depends on how big your boxes are and how many you have, right? I mean, we have a lot of boxes. I mean, to give you an example, I think one of our clusters has 250 nodes. So we have 250 commodity boxes running, one M3DB cluster. And we can add more and then give it more capacity. So it's just... Perfect. So we actually support variable retention and resolution. So the same cluster is handling different ones. Our default is 10 seconds, but resolution is 10 seconds and and retention is 2 weeks. And we also do resolution 1 minute and retention 1 month. But we actually have a use case wherein we provide 5 years worth of retention. So that's the one which does the trip forecasting. Yeah, I mean, you can easily do 1 minute in 6 months if you like. So I think 1 minute is a pretty reasonable resolution. And I think more than 6 months of data, you really need some other system needing it. Otherwise, you don't really want to look at it.
I have a somewhat flippant answer, which is tell them how much it's going to cost. A lot of times people say, I want maximum precision for infinite amount of time. And say, yes, you can get that for this price. And then they'll change their mind.
So we're pretty much out of time, but we have one last question, which already was assigned. So go ahead.
Yeah, so just quickly, I wanted to follow up on something that was just mentioned before about the various formats that are used to store, like there was V1, now it's V2. And with long-term storage, of course, you have to ask yourself, okay, now there is format V3, Prometheus stops supporting older formats. Is it something that, I don't know, for your various versions of remote storage, something that you already thought about? How will you deal with this? How will you, I don't know, convert all data or continue supporting the old storage format?
I think the only solution that has gonna have problems with that is Thanos, because you all have your own format in the end, right?
So ours is Prometheus 1 format, right? The chunks themselves.
Yeah, but you're basically free to decide when you change anything about it, right?
We've copied the code into our code base now, so we just choose support the data forever.
Yeah. Sorry. Yeah, and Thanos basically is actually copying the data in the storage format as is, which can be a problem, yes. But the format is entirely versioned, right? So whenever we add a new version, we just re-render the TSDB library into Thanos, and then we can also read the new format. That's so far the theory. You of course have to be careful that you don't upgrade your Prometheus server that then produce unreadable data before you upgrade your Thanos cluster, right? And in theory, if at some point Prometheus totally changes its format, yeah, then we will have to see what's going to happen. But I think that's very far away.
Thanks.
Okay, thank you very much.